Hi everyone. Following Louise's talk, I've got another one relating to crime and forensic science. So when a crime is committed, glass is often broken, whether this be a case of a breaking and entering or a hit and run accident. And forensic scientists are often given the task of analyzing this glass in a number of different ways. And one particular way, type of analysis is analysis of the transfer of glass. And what I mean by this is that when someone breaks a window, for example, many tiny little fragments of glass are transferred from the broken window to the person's clothing. And then when police apprehend a suspect, forensic scientists can collect the broken glass from their clothing, and they're often tasked with determining whether the glass found on the suspect's clothing matches glass found at the crime scene. To measure this, historically, refractive index has been used. This is something which is very easy to measure. All people need to do is shine a laser through the glass and it can be measured, but it doesn't have a fantastic discriminating capability in that two entirely distinct pieces of glass from different sources could have the same refractive index. As a result, measurement of the elemental composition of the glass has become increasingly popular in recent years. This is measurement of elemental concentrations of about 20 different elements. And in Australia, we measure this using laser ablation inductively coupled plasma mass spectrometry, or LA-ICPMS, where the samples are basically vaporized, then ionized, and the ionized sample is then has its elemental concentrations measured with a mass spectrometer. When it comes to then analyzing this data, the current best practice are some interval-based methods. In this scenario, the data found at the crime scene, so the glass samples from the crime scene, for each element individually, intervals are constructed about the mean. And then for the samples found on a suspect's clothing, their elemental concentrations are compared to each of these intervals individually. And if all of them match, the samples are said to be matching. And if any single elemental concentration is outside of the interval, they're said to be non-matching. This, of course, doesn't take into account any correlations between the elements. So we've started looking into some new methods which take this into account, particularly some machine learning classification-based methods, particularly random forests and Bayesian additive regression trees. And we're also looking into some methods involving using statistical distances. Hotelling's t-squared test is already being used by some people, but we're also looking at using a Bayesian treatment for these distances to get a more definite match criterion and potentially also working out some kind of probability of match between samples found at the crime scene and found on suspects' clothing. We've been working in collaboration with Forensic Science South Australia to build a database of elemental composition from all Australian casework. So this database will be such that any new data can just be uploaded and automatically cleaned and processed. And then the app will provide a visual interface allowing analysis to be performed, and all of the tools that are needed for that will be included in this app. Thanks. Does anyone have any questions?